This is one of our tractor mounted sensors, which is colloquially called the Forage Sensor Box. The official title of it is the ACS 214, and it's a commercial product available through Holland Scientific. These are sensors that are low cost and able to be mounted on a tractor like this as growers go about their daily operations, such as spraying a field with either herbicide or nitrogen. This is a tool that can also be mounted on a monopod and carried across the field in smaller operations that may not have that big kind of equipment. What's unique about the Forage Sensor Box is that it has 3 different types of sensors in it. It has 2 active sensors that produce either sound waves or lasers that can quantify the canopy height as the tractor goes across the field. It also has a spectral sensor which is able to quantify the amount of greenness on the field. And those 3 sensors together can help us map cover crop biomass effectively across the field. What's really cool about the Forage Sensor Box is that in conjunction with satellite imagery, we're able to push our estimations of cover crop biomass up to about 4,500 kilograms per hectare, which is much higher than we've been able to do with our multispectral satellites. Again, this is an easy to operate tool, and we expect it to be really big in the future in terms of producing this across a wide network in PSA. So in this lightweight piece of technology, we have 3 different kinds of sensors that you can see here. So up here we have our time-of-flight lasers, also can be known as LiDAR systems. This actively shoots out a laser at about 900 nanometers, and it will bounce off a target and come back, and we quantify the amount of time it took to come back to the sensor, and that can give us an estimate of how far away a target is or how tall the cover crop would be. Similarly, this is a sonic sensor here, which sends out a similar kind of pulse as our laser, except it's got a wider kind of footprint that you see. And it does a similar thing where we time the time that the signal was sent out and bounces back to the canopy to the sensor. So this kind of tells us more about the shape of the overall canopy. This is more of a point measurement that tells us about the gappiness in the canopy.